Hi, in this video we are going to study the semiconductors. We all know that semiconductors are types of solids which have conductivity in between conductors and insulators. Now, silicon is a semiconductor and we know that solids have specific orientations of their atoms and these atoms share their electrons. We have seen in previous video that how they share their electrons and how valence band and conduction band are formed. Now, semiconductors are of two types, intrinsic semiconductor and extrinsic semiconductor. We know that in solid crystals there are atoms which have their positions. If all the atoms are same, that means the crystal is pure. That means all the atoms are same. If here we have silicon atom for semiconductor, that means in the crystal array we have all the atoms as silicon atom. So this is a pure crystal and these type of solid crystal of semiconductors are named intrinsic semiconductors. In contrast, extrinsic semiconductors are those semiconductors in which one or the other impurity is present in the crystal. Example, silicon. We know the atomic number of silicon is 14. So configuration 284. That means 4 valence electrons in the silicon atom. Here this is the 2D array of silicon pure crystal. That means intrinsic semiconductors array. There are 4 valence electrons for each atom and they share 4 other electrons from the neighboring atom and complete their orbit. If we replace this silicon atom by any other atom, suppose an atom with 5 valence electrons or an atom with 3 valence electrons, the atom of the similar size will fit into the structure in place of silicon atom. So that means that atom is impurity to the whole crystal. This adding of impurity is called doping, and those crystals which have impurity in them are called extrinsic semiconductors. Now in this video we are going to deal with intrinsic semiconductors, that how these intrinsic semiconductors conduct electricity. So for this, see this diagram. This is 2D array of the silicon semiconductor which is completely pure, that is intrinsic. Now we know to conduct electricity there should be charges and those charges should have movement because current is the flow of charge. Here we can see that electrons are present. So according to us, the electrons are only the charged particles which can move to conduct electricity. Yes, electrons move in semiconductors to conduct electricity, but this case is little bit different. How it is different? See, if the temperature is 0 Kelvin, that means at absolute temperature, there is no movement of electrons because they have that much energy which make them bound to their atoms. This is covalent bond between the atoms which have electrons. There is no movement of electrons. This crystal will remain as it is. That means at 0 Kelvin there is gonna be no movement of charge. That means no current. So at absolute temperature, semiconductors are perfect insulators. Now, if we talk about room temperature, what happens? At room temperature, thermal agitation will be produced in this crystal. That means electrons gain energy. Now, we know that valence electrons of the atoms are present in valence bond of the solid. Now, we have seen in the previous video that this valence band is completely filled. As we can see that the valence orbit of each atom is completely filled and that means this band is completely filled. Now, the electrons can't move here. So how can they move and conduct current? What happens is, this is the energy band of the electron. At room temperature, the electrons gain energy. That means they shift from this energy band. That means they gain energy and try to jump over this band. And we know above valence band there is conduction band. So at room temperature, the electron of this bond gains energy and breaks its bond and jumps to the conduction band. Now 1, 2, 3, many electrons can do it. We are just talking about one atom here. Now in this atom, suppose this bond breaks. That means the electron which was having energy in this band has gained energy because of thermal agitation and has broken its bond because now it has gained energy and it will move fastly. So it has moved away from its position and jumped to a higher energy level. That means it has reached conduction band. So practically the electron has not moved out of the crystal. It has just moved away from its place. It has just broken its bond and has a random motion in the crystal now. As we can see here, the electron of this bond has shifted from its place, has broken its bond and has a random motion now. So what happens? We get to know that the current is produced because of free electrons. So now we have got a free electron. Earlier this electron was at its valence position, so it was called valence electron. Now it is free, so it is called free electron, and the current is produced because of free electrons. Now as we can see that this space which actually had that electron is empty now, so this is called hole. But one thing has to be kept in mind, that hole doesn't mean vacuum. Now suppose I am standing here, I shift my place to here. That means this place has vacuum. No, this is not thing. This is the thing that it first had something, but now it has capacity to attain something. So this hole is actually, we can consider it as an atom which had 8 electrons around it. Now 1 electron has moved away. So what happens? This atom has tendency to gain an electron. So hole is not a specific space in the atom, or we can't, here we are showing it as a space, but actually it is an atom which can accommodate 1 electron. So if I represent hole here, now this semiconductor is neutral. We know that it does not have any charge on it. So if I talk about this position only, earlier it was neutral. Now 1 electron has moved away. That means negative charge has been taken out. If a thing was neutral and now negative thing has taken out of it, what happens? That means positive charge has remained. So it is said that this hole has positive charge. And this positive charge is equal to the charge of the electron. That is why this semiconductor is neutral. Now, free electrons have random motion in conduction band. That means this electron which was earlier present in this valence band has gained energy and jumped to the conduction band, and now it has free space to move. We know valence band is completely filled. Electrons can't move here. It has gained energy, moved to the conduction band. This is free, so and it has space to move. So the electrons have free space to move. These are free electrons. Now, we can see that holes have positive charge, electrons have negative charge, and current is produced because of movement of charges. Here we have shown that current in the semiconductor is because of the movement of the electron. That means free electrons move and current is produced. But this hole also moves. Now we have said that hole is like an atom. It's just an atom which has capacity to accommodate 1 electron. That in crystal this atom is going to move. No, we are showing this hole as a particle here which is positive charge. The movement of hole is going to be like this. See, this is an atom which can acquire 1 electron to fill its orbit. So it will attract electron from the neighboring atoms. So if we see that this is the neighboring atom of this atom which can acquire 1 electron, it will attract electron from it, and this electron will break its covalent bond because it has room temperature, energy is being going on, that means thermal agitation is going on. This electron will break its covalent bond and will come here to fill this hole. So what happens? This valence electron has jumped into the hole. So this hole and electron get paired up and a simple electron comes here and this atom get completed. Now earlier the hole was here, but as the electron has jumped here, so that means vacancy is created here now. So what we can see, that earlier the hole was here, now it has reached here. So actually the hole hasn't moved, that means the atom hasn't moved, but it is the movement of the electron. But as we can see the positive charge, so we say that the hole has moved from this to this. So this is the movement of hole. Actually this is the movement of electron only. These electrons movement is valence electrons. That means the electron which has broken its covalent bond has not jumped to the conduction band after their gaining energy. They have moved in the valence band only and shifted this hole. So we can see that when the electron has jumped to the conduction band, free electron is produced. At the same time a hole is produced and this hole also moves in valence band. How it moves? That the electron from the neighboring atom jumps into it, fulfill its place, and next place acquired by the hole is this. Similarly, now this atom has tendency to acquire one electron, so it will attract electron from its neighboring atom. Suppose this electron jumps to fulfill its requirement. So what happens? This electron comes here, this space gets fully filled, there is vacancy here now. So we can see initially the hole was here, but now it is here. So we can see that there is movement of hole. So we say that negative charged free electrons move in conduction band and contribute towards the current in semiconductor, and the positive charged holes move in the valence band and contribute towards the current in semiconductors. So this is how whole current is produced. We know that this is a random motion because free electron can move here, 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 then this, then this. It's a random motion. Similarly, holes have random motion. But if I apply potential difference across this semiconductor, what will happen? The electrons will be aligned in one direction, the holes will move in one direction. So there will be current flowing in the semiconductor. So we have seen that the current in intrinsic semiconductor, here we are talking about intrinsic semiconductor, the current is because of current of holes and current of free electrons. And electrons and holes, I am talking about free electrons, not valence electrons. The electrons and holes are always made in pairs. So we have seen that the number of free electrons is always equals to the number of holes in intrinsic semiconductors. That is, a electron moves and a hole is created. So free electron and holes are always equal in number in intrinsic semiconductors. So this is whole theory of the intrinsic semiconductor.